Oh, okay. So basically the idea of today's prep is for you guys to help through assignment questions 5 to 8. Okay. I've got some examples for 5 to 6. Question 8, I've started the Mathematica code, but which I will be completing if we have time today or later on. Okay, and then I will post all my codes are available in course GitHub, which is Yoni's GitHub folder, MATH7501. So Prac 1, Prac 2, all codes are completed and available there. Please have a look at that. Okay, if you guys have any questions from Prac 1, Prac 2, can you please let me know now? On Piazza, I know there were so many, some of you were confused about how to compute A inverse, which I think I've got here. Let me go through. So this is Prac 2, which is completed with codes and available. How can we type sets in Mathematica? You can use a list. We will see today. Okay, you can show it as a list. Okay. Okay. So there were some questions about question 4. The last part, how to take inverse. So I've given an example here, which you can use, which I hope you will help you to do the last part of question 4. So it's really asking you to find A theta inverse. Okay, that's to me, that questions. That's how I interpreted the question. So this is an example where I've got a reflection matrix and I've gone through the determinant finding A times A and inverse. Please have a look at that if you have any doubts. Let me know today. Okay, coming back to today's prac. Question 1 is about set operations, like finding the cardinality, which is the like how many elements are in the set, whether an element is a member of a set, finding subsets and power set of a set. Okay, in your assignment, unless you have been asked to use Mathematica, you can compute these sets using by hand, and then submit your assignment. So here I've shown you how to, and you can always use Mathematica to check your solutions. Okay, here I have computed, I've asked you to find, suppose A is his elements, 1, 2, and a set 3, determine if the following statements are true or false. The first part is how many elements are like this 2 to the power A is the power set. Okay, so if you want to do this by hand, because it's got 3 elements, it's easy to do. Let me show you the calculation of how to compute power sets by hand. The power set is all possible subsets, including the empty set and the set itself. Okay, so I need to go to my iPad. So I'll stop this screen. Sure. Okay, the question which I've given was so I got A equals, I think 3 elements, it doesn't matter. That's 1, 2, and the set 3. Do you guys see my laptop, right? iPad, right? Okay. So it's 1. Okay. 1, 2, and 3. Okay. Now this one, the power set, it consists of all the subsets of A. Okay. So so how many subsets are there? Okay, that is given by, if you look at your lecture notes, is 2 to the power, 2 to the power, the number of elements. So it's 1, 1, 2, 3, which is equal to 8. So you should get 8 subsets. Okay, if you could write down, so I'll say this is so let's say this is power set of A. You got the first is 1 is subset, 2 and 3, and then 2 elements, 1 and 2, 2 and the set 3, and 1 and the set 3, and the next one is, so it's bigger, 1, 2, 3, 4, 5, 6. The next is the 7th one, which is the empty set, and the set itself. 1, 2, 3. Okay, so it's 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's the power set. And the next question I've asked is, given this set, let me check. So it's so part A is asking you to check whether the number of elements in 2 to the power A, which is the power set, is it the same as 2 to the power the number of elements in A? Okay, we know that the number of elements in the power set is 8, and 2 to the power 8 is 8, so that's true. Okay. Second question is 3 subset of A? Okay. Sorry. Is the set 3 subset of A? Okay. Sorry, is the element 3 the subset of A? I don't have it here, but 3 I have, but it's a set of sets. Okay, so this should not be true. And part C is 1, 2. A subs is an element of the power set. Is 1, 2, and is the set 1, 2 an element of the power set? Yes, we got 1, 2 here, so that should be true. Okay. And so let's look at another set where I have maybe B is equal to let's say 1, 2, 4, 5. Okay, and I want to ask what is A intersection B? What is A intersection B? That is the elements common to both A and B, which is equal to 1 and 2. And the next part I want to, I haven't put these questions, but this is just a demonstration. What is A union B, which is equal to all the elements in A and B, the set A and B. So we go 1, 2, the set 3, 4, 5. Okay. 1, 2, the set 3, and 4, 5. And the other thing I wanted to ask is, okay. What is A complement? Okay, that is A complement intersection with B. To do this, A complement is like, let's say the entire space is natural numbers. So it's 1, 2, so except 1, 2, and the set 3. So intersection with the set B would be just so A complement would be, if we look at the natural numbers, A complement is all the natural numbers except A. So A complement intersection with B would be whatever which is inside B, which is 4, 5. Okay. Is there any questions so far? Yeah, All right. So let's look at how you can check your answers in Mathematica. This is a very small set, so you don't like, this is pretty easy to do by hand. But if you look at Mathematica, you can use these functions to find, you can use length function to find the number of elements, which is the cardinality, and subsets function for all the, to compute the all the subsets of a set. Okay, if you want to do this here, let me check this one. So let me first compute length of A, which should give you 3. Or maybe I have A somewhere written previously. Define. Okay, what I'll do is I'll go through this code which I have done here previously. So I've defined here A is 1, 2, 3, and to get the power set, okay, let's look at the power sets of A, okay, which is what we got in our handwritten notes. And let's look at the length of this power set. The length is 8. Okay, and let's check this one. Okay, which is true. And that's what we got. Okay. Okay, and okay, is that clear to everyone? Now, in this part, I am checking whether 3 is an Okay, the first part is I am checking whether the set 3 is an element of A, which should give you true. So let's look at this. Yeah. And then the next part, I am assuming it should be false. Yep. Okay, because we don't have the element 3 in the set. Okay, is that clear? And the next one, we want to check whether 1, 2 is an element of the power set. Okay. Set 1, 2 is an element of the power set. So you can use the function member Q function, which uses that. Okay. So this is just a compact form. You have previously found what are the subsets, but I've used it here again. And what this function is asking you to is 1, 2 subset of A of the is subset of the power set, okay, which we get is true. Okay, and let me clear A. Okay, any questions so far? Okay, question 2. Question 2, I've asked you, I've given, like, this is a similar example, which is given in your assignment question. So if A is the set where K is question 7, yeah, similar to question 7, what I just did, yes. Do we go to Mathematica to solve these questions or by hand? No, unless your assignment specifically asks you to write a Mathematica program or code or check it using your program, Mathematica, then you don't need, you can use your hand calculation to do that. I've asked you because like sometimes I've used a simple example where you can use hand, but sometimes there could be situations where you like the set is large. So you can use Mathematica to check or get an intuition of what you should be getting, yeah, by hand. Question 2 is describe a set. A is K is an integer such that K is divisible by 2. B is the set B has elements where K is an integer and K plus 1 is divisible by 2. Okay, what does it mean if a number is divisible by another number? Let me write some notes here so that this is for your clarity. If like this is straight from your notes. So if n is divisible by a number b, okay, then there exists an integer such that, yeah, first one is form 2k and the second one is of the form 2k plus 1. Yeah, that's true. So that means the element of set is in the form 2k. Yeah, the other one is 2k plus 1. Okay, so like these are infinite sets. So I don't think there is a general rule where you can represent the infinite sets in Mathematica. I haven't found yet, unless you use a special package. So I'm going to illustrate some this example on by hand. You can also show this type. Just okay. So if you look at some k values, so I took k is equal to let's say k 1 to 6 and then so on, and k plus 1 is you add one more to that, and then if you could write down the set, illustrate the set A and B, and then figure out so A should be k plus 1 is divisible by n means by 2 means k plus 1 should be written in terms of 2n. Okay, that's what to me. So A intersection B is really the set B, which I got here. And what is the set of natural numbers, like the complement of A union B? Okay, so again, I've illustrated here, which I got as A union B is A, and then whatever which is not in A is the complement. So it's written in the set notation where it's K such that K is not divisible by 2. Okay. And part C, I've asked, like I've given a set C where K is a natural number and K is less than or equal to R for a given R integer. Then what is the cardinality, that is the number of elements in A intersection C. Okay, here I took R as 10. Okay, this is again an illustration, but you are supposed to write this on Mathematica. Okay, so if you took K equals 1, 2, 3, 4, 5, 6, and up to R, then CR is this matrix. And A, or I have restricted to this R equals, yeah, K equals this one. And then I got the cardinality as 5. Okay, but you could go on like this. Okay, but this is just an example where just to I have used an example. You could check this. Okay, I've used the same K value here. Okay, so it happens that this is an example where that's a good question which I haven't explored. I don't need to figure it out. Okay. Thanks. Okay. Let me go to. This one, okay, the simulation, I have performed it here. Okay, so I took R equals 10 and then use the table to compute the list of elements of CR and elements of A, and found the intersection here. So if we go through this example, okay, this is just one example where I and if you want to do this for a given R, you could do it using a module function where you every time you give an R, compute C, compute A, and find the intersection, and then produce the length. Okay, so if I say R equals 10, okay, 3. Oh, this is 2 and should be 2. Okay, that's what we got by hand calculation. Now you can increase the number to 2 and to 10, 50, 100. 100. Okay. All right. Okay, the next question is, this is a very famous example in statistics, so regression line, estimating these regression coefficients. Okay, so the first question I've asked is, so given matrix A, matrix Y, okay, generate a million random entries from 0 to 5 for beta, B0, B1, and estimate beta, which minimizes the least square, which is A, B minus A times beta minus the Y. Okay. If you go through some example, okay, so what does all this mean? Let me illustrate this. Okay, this is an example just to demonstrate how this should work. Okay. For example, you are given some data points. Okay, let's say 1 1, 2 2, 3 2. Okay, and what this question is asking is what is the line of best fit? Okay, if you go 1 1, 2 2, and 3 2. Okay, you want to predict a line which passes through which is the best predictor of these points. So that's what we are doing. So usually this line is the expectation. That is something like B0 plus B1 of your X. Okay, and we need to estimate this question is asking you estimate B0, B1, okay, which minimizes this distance, okay, the error, okay, when you predict, okay, minimizes those errors. Okay, so how do we proceed with this one? So if you apply that function here, the first point, 1 1 is really B0 plus B1. Okay, X is 1, Y is 1. And the next point, 2 2 is B0 plus 2B1 equals 2. The next point, 3 2 gives you B0 plus 3B1 equals 2. In matrix form, this part is written as 1, 2, 3, and your B0, B1 equals your Y, 1, 2, 2. So this is what the question is asking. Given matrix A, matrix Y, find your B. Okay, find B. Okay, so this is usually computed using something like this. So the error which you estimate is given by every time you apply this equation, you get an error, which is your data point, yi minus f of your xi. Okay, that's your error, and we want to minimize this error by some measure. Okay, so the measure we use is the mean squared error, which is equal to sum of yi minus your f of xi squared, and this goes from 1 to your data point. Okay, so every time the question is asking you generate a million beta values. Okay, so b0, b1. Okay, for each beta value, okay, compute this one and then find the minimum. Find the minimum. Okay, and what is the beta value that minimizes the function? Okay, that's the idea. Any question? Okay, I'll show the simulation which I did. So you can visualize this is I started with this one. Let my beta be random real numbers between 0 and 1. Here, this term it says like 2, 3 means 2 by 3, and take two points 3 times, and that's the third element. Let me run this one. Beta. Okay, I want to see what our beta is. Okay, and beta all, and then if you want to extract the third row, okay, or each row, that's how you do it. So I started building this function like that, and then once you generate beta, you can compute the error term using a beta, like for each column, and subtract it by y, okay, and then use the norm function to compute the squared norm of the error. Okay. Okay, so that's the idea I started with, and then putting everything together in this function, line fit function. And run is like how many samples or how many beta values you want, and using the module function. So this basically says take 2 random real points for n times. And this norm is where I want to store the norm. This is at the beginning constant array of zeros, and where I will fill in later on. And then for I goes from 1 to n less than n plus 1. Compute the error for each I. This part says for each column of beta, compute a times beta minus y, and find the norm, and compute the minimum of the norm list. And I wanted to check what is the minimum, so print minimum. And then in this norm matrix or norm list, I want to see which position the minimum is, okay? And that is given by index, and then use that index to find the beta which minimized it, okay? Corresponding to minimum. Okay? Okay, I hope that all those make sense. Okay, any questions? Okay, let me run through this. Maybe 10 samples. Oops, something went wrong. Oh, this did work. Oh, I didn't specify why. That's why. Now it should work. Okay. So the estimated beta 0 was 0.4, and beta 1, that's the slope, 0.7. Okay, and usually by hand calculation, the estimates for beta computed using this matrix. That is a transpose of A times IA, take inverse multiplied by transpose of IA and times by Y. Okay, so you can check whether your estimate is close to the actual value, which I got here is like 0.5, which is close to that, and 0.8, which is again close to that. So if you do this a million times, you should see these two numbers getting very close, okay? And the third part, I've asked you to plot the points, your original data points, and the line of best fit, where you sub your beta 0 and beta 1 using the estimates, which requires me to use list plot and line, plot the line. So I've given that. Okay. So that's the line which I got, because the slope is very small. It's almost a horizontal line, okay, which we could expect. Okay. And the next part, I wanted to show like the solutions of the equation. This solution. Yeah. Find all solutions of this equation where n is, oh, I didn't specify n, okay. In this case, k is 2, n is 3, okay. First, like how many, to get how many solutions would this equation give? It's a binomial coefficient. If you evaluate this binomial coefficient for n is 3, k is 2, I got 6 solutions. Okay, so the idea to do this is like, my idea to do the code is like this. Okay, so if you specify the first variable, that is x1, to be some numbers, so then given x1, use recursion to find, generate solutions to x2 and x3 and so on. Okay, I'll complete this and provide the codes later on. Is there any questions so far? Cost function in, there's a question which says cos theta times cos theta is cos squared. I think it should be. Cos is a function in Mathematica, so you should use capital C and square brackets. Julian, k element of n divisible by 2. Is the intersection not empty? Can you give an example? We are running out of time. I've got another tute. Could you please post your questions on Piazza? I need to stop the recording.